Hello, everybody. Welcome back to the Routing Loop. And today I am joined by the infamous Matt Lewis, as well as by Jordan. I'm not going to try. I know Rojas Garcia. Is that correct? Am I
Yeah,
pronouncing it correct?
that's actually right. Yeah.
All right. All right. Good. Good. I always try to get folks' names right because, it's their names. Just a quick recap of the mission statement for all of you folks who are new today and joining us. This is a weekly show. We talk about building with AWS networking constructs, things that are new, architectural designs, all the cool things. It's been a while since Matt and I have been on together, I think. And I see Dominic says hello. One of the friends of the show has been around for a while.
Dominic.
Hey, Dominic. How you doing? So what I'm going to do, though, seeing how we know Matt, because he's also one of the hosts, Jordan, I'm going to give you a chance to kind of tell everybody who you are and what you do for AWS and why you're here.
Sure. Hi, everyone. My name is Jordan. I'm a networking specialist, solutions architect. I've been in AWS for 6.5 years, and I focus on connectivity services. Connectivity services being Direct Connect, Cloud One, Transit Gateway, VPN, etc., etc. Happy to be here, guys.
Awesome. And
Right,
today, Matt, what are we talking about?
We are talking about connectivity services. So I think you're at the right place, Jordan.
Yeah,
Okay.
I think so.
Good to know. Good to know.
See, what I think is that it was supposed to be Matt's job to do all the connectivity service introduction, and he's like, I don't know, I'm overwhelmed, and he needed Jordan's help. So I'm just kidding. Of course.
I did say on my LinkedIn post that says we're going live today that I have 0 slides prepared. And I think I'm going to double down on that and say we're not doing slides today. 0 slides. Even though we have a whole library. We
like
have
4 different
presentations. Presentations about this stuff.
Yeah.
We'll see how that goes, though.
We'll see how it goes. So, and Ken said hello. I had Ken and Hitherings as well. Okay,
Hitherings,
so
Ken?
let's see if we can kind of get this party started. Unless you want to do your introduction again, Matt. Why don't you kind of lead us on what is connectivity in AWS? I mean, connectivity in traditional networking has always been like drawing cables and plugging things in and whatnot, but it's a little different in the cloud. So why don't you kind of kick us off a bit and let us know what it means and maybe a little bit of the differences between traditional and cloud connectivity, and then we can hopefully get into the evolution.
Yeah, let's get in there. So using a whiteboard right now. For folks that are interested in my setup, I'm actually using a iPad with a USB-C cable to laptop, and then using QuickTime to just look at my iPad screen. We also sometimes use a tool that's called Miro. It's okay. It's basically like a shared whiteboarding tool. We may transition from what I'm using here. I think I'm using Notability or something, but we may transition from that into Miro if we want to share some diagrams. But let's get started. It's been a while since I've done live whiteboarding, so if this doesn't work very well, then we'll figure it out. But here we go. We've got a rectangle.
We're starting.
We're getting started.
That's a good beginning.
It's a good beginning. So VPC. I don't want to go too kind of 100 level, because I know some folks on here are like pros like Dominic and Ken and Heathering and others that know this stuff like intimately. But for folks who don't know, VPC is basically you could think of it like a portion of the cloud that's your own. When we first built VPC, we said we want to give folks a virtual data center. We want to say, hey, here's a virtual data center that you can spin up all of your infrastructure in, and it's yours. And funnily enough, speaking from a connectivity perspective, we have this thing called a VGW, and I don't know if I'll use this one here. Just kind of getting my whiteboarding legs back here. We have this thing called a VGW, which attaches to a VPC and allows outside connectivity, and we'll get to this, but the original VPC actually looked like this. That was it. There was no internet gateway. There was nothing. It was a stub. Actually, I was talking to Eric Brandwine the other day, and he used a term I hadn't heard of in terms of VPC. So for folks who don't know Eric Brandwine, check out Another Day, Another Million Packets. I think, is that right, Jamie?
Yeah. Another day, another billion flows.
We'll post the link in there. It's a very old session now, but it basically goes into how VPC was built. And he called VPC a cul-de-sac. So it's basically a road that you go in and there's a circle, right? A cul-de-sac. So it's basically you configure your compute inside the VPC and traffic can come in and go out again. It's like a stub. It's like a stub network. That was the original VPC. But then, let's do some different erasing here. But then we basically saw and heard from customers that they wanted to do internet connectivity. And so we built this thing called a internet gateway. It's actually a massive, massive scalable fleet of things, instances of compute that does network address translation from the outside world to the inside world. And so you've got a 10.0.0.0/24. I said I wasn't going to do 100 level, and I'm going really 100, but I think that's fine. You've basically got subnets within your VPC where your little boxes here, let me redraw those as what are actually EC2 instances in blue. So this is
And I did
subnet.
pop up the YouTube link up there for another day.
Oh, great. Yeah, I think it's an old one. It's a little out of date on the way that we do what we call the mapping service, and I want to talk about that in a second. But effectively, it's a good intro. Anyway, so we've got in blue here, we've got these EC2 instances, and then we basically have traffic going in from an IGW. We do a one-to-one NAT here from a outside address to an inside address, which could be here, 10.0.1.25. And so basically you've got this thing that you control, and you've got connectivity coming in from an IGW, an internet gateway. You've got connectivity coming in from a VGW, which could be VPN, or it could be DX, which we'll talk about. But you've essentially deployed some compute and you've got connectivity to it, however you want. But the thing is about VPC, we said originally, and there's a quote that Dave Brown always says in his innovation session at reInvent. I think last year we had Cole McCarthy, who's awesome, super awesome security expert in AWS and networking too. But the year before we had Dave Brown, and he generally says when we developed VPC, and he was there when we did it, just like Eric Brandwein, we wanted to give every customer one. Every customer gets one VPC. That's it. But we didn't put a limit on that. Right? We didn't go into Jamie or Jordan's account and say, oh, you can only configure one and that's it. We said you can configure as many as you want, because really it's not even a memory consumption thing on our part. You can have as many VPCs as you want. What consumes memory in here, or what consumes resources, I should say, is the EC2 instances, and in the VPC, the IP addresses inside the VPC, and I'll come to that. Right? But what we actually saw was customers say, okay, that's cool, but what if that's one app? What if we say this is app one? I'm going to build another VPC over here. Actually, I really like how that looks with the let me fix this. Jamie knows I have a little bit of OCD when it comes to drawing and making things look pretty, but
I think that's a common ailment for most people in networking anyway.
Okay, so we've got another VPC over here. Thanks for making me feel not so unique.
Not just you, buddy.
It's not just
a sickness.
Okay, so this could be app 2, and we have, I don't know what that is, VPC 2, right? And so we have another VPC in here with some subnets, 10.0.1.0/24. It could be the same side range or a different whatever. But then we also have some compute inside this VPC, inside this subnet. And actually what I'm going to do here, I'm just going to fix our side range, because this will be a 10.1.0.26, and this can be a 10.1.0.0/16, and this is going to be a /16 actually. And so now what we can do is, well, I'll finish my thought. Customers started deploying not just 2 or 4 or 8 of these, they started deploying thousands.
Yeah.
We have customers that have like, let me ask you guys, like Jordan, how many VPCs have you seen a customer have? No customer, names, just in general.
Yeah, no, hundreds, especially as you say, like customers like to have this like border in there, like they have an application, they put it in there. So I'm talking about hundreds. And anyway, I'll let you continue. I know where you're going, but yes, absolutely. I'm seeing.
Well, what's the most? What's the most you've ever seen from a customer? TechFuel.
Yeah, you got to beat TechFuel. He's already up to. He's already at 3,520.
More than 500. I can't remember exactly the number, but more than 500. I've seen it.
The highest I've seen, if I can pipe in, was from a large FinServ company. It was around 12,000. Okay. And they had a process to create them and destroy them at will. Like they use VPCs like we talk about EC2 instances these days.
Oh, look, we have someone.
It's a software-defined construct, right? Yeah. Sorry,
yeah,
go, John.
we have someone in the chat, TechFool, saying we have 3,523 VPCs. So that's a good use case.
There's a customer that told me they want 100,000 VPCs. They're like, "Can I do 100,000 VPCs?" And I'm like, "Yeah, sure." I mean, we have millions of customers, right?
Yeah.
And you would assume that those customers have many VPCs. Like, it's not a limiting factor for us. It's a software-defined construct within our platform. And so when we talk about connectivity, basically you've got connectivity inside the VPC. I'll call this intra VPC, where apps can talk to each other with security groups and NACLs and other things. And that's all pretty straightforward. And we could do a whole session on this, but if you wanted to deploy a firewall in a subnet over here, you could send traffic to a firewall before it goes on to another host or something like that inside the VPC. So intra VPC, you've got a whole bunch of topologies. Intra AWS, you've got a whole bunch of options too. And so what I'll talk about are some of the limiting factors. And so you can use what's called VPC peering, PCX123, and this could be PCX, 123, whatever. And so what you can basically do is connect a peering connection between two VPCs. Pretty straightforward. Now, the beauty of the AWS platform is when you've got a EC2 instance like we have here, it basically is a guest OS sitting on top of a physical piece of hardware. There's a VPC ID as the packet comes out of the physical hardware and hits our underlay network. The underlay network, the Nitro card, will basically take the packet and put a VPC tag on it and say, "You're in VPC A," or in this case, sorry, VPC 2. You're in VPC 2, and you can talk to other things in VPC 2. But what peering does is say, well, actually, let's do a purple here. I want to talk to a host over here in this other VPC. Physically, let's draw and it's been a long time since I've drawn a rack in a data center, but away we go. Physically, let's draw two racks. There could be two racks with some top of rack switching to some kind of leaf and spine topology. Yes, we use like cloud
Those
networks.
are
and
outposts.
Kind of
I mean, you're not just drawing an outpost.
We can talk about outposts, but that's different.
I know.
Jamie's teasing me because I was on the outpost service team when we launched it. A great product. We can talk about that. But these two hosts could be right next to each other, right? Or they could be on the same rack, right? You could have a placement group and they could be sitting on the same rack. But the point being, they're going across VPCs now, right? And so you think, oh, I'm going to have a bunch of latency. There's going to be a bunch of interconnectivity. Not necessarily. We take the tag from VPC 2 and we turn it into VPC 1 and send the packet on to this host, which basically then says, hey, this packet is going like so between two hosts. And so what you'll find is, if I draw I'll use a different color here because we're getting messy. It's turned into chicken scratch territory. But A and B talking to each other could be 1 millisecond of latency. A and C down here could also be 1 millisecond of latency because you're not going through any intermediary hops to go between those VPCs. So that's
as long as they're in the same region.
As long as they're in the same region, correct. That's a good difference.
Yes, good call out. You can do it across regions too.
So let's erase some stuff. What we're actually doing when you go across regions is, I'll draw another VPC here. I don't want to go too far into the cross-region thing because we got so many other things we want to talk about. But if there's a green VPC over here and it's in another region and we've got a peering connection with, this is VPC 3, you're actually going across our inter-region fabric. And we're encrypting that traffic and sending you across our backbone. So let's say it's from US East 1 in North Virginia to EU East 1 I'm making up names here. EU East 1, is that London Heathrow? Or is that Dublin region, I think.
Something like, yeah.
I don't operate in the EU too much, but because my default account is here, I shouldn't say that. But effectively, this could be a 200 millisecond latency because of the speed of light going from North Virginia up into Dublin in Ireland, right? So there's some differences there.
But I just want to point out, just really, really quickly on that 200 milliseconds, that's actually really, really good. If you think about it, we control all of our own fiber, which is explained in that video, a dual collapsed 100 gig backbone, right? Whereas you could experience, like if you're using MPLS or something else, multiple tier 1 to tier 3 providers in between, which every hop has a cost, right? It always adds latency. So I just wanted to point out, because of the fact that we control all of our fiber and we don't use anybody else for our backbone, that 200 milliseconds is actually very impressive.
There's actually a term which I love. I don't know if it's a renowned industry term, but one of our internal network engineers once said, we do cold potato routing. So when I was in a service provider, we used to do hot potato routing, where imagine you get a packet, which is a hot potato, and you pass it on to another network as quick as possible. Cold potato is, I want to hold on to this packet as long as possible because our network, we feel, is the best place for it. And so instead of palming it off onto a transit provider, we keep it on our network and pass it all the way along our network to the destination as far as possible. I'm just looking at the comments here. There's a bunch. I love the comment from Mike P. Funk saying that all of TechFuelD's VPCs are connected to one transit gateway. You could do that.
You could. Well, up to 5,000, I guess. Not
up to 5,000.
Yeah.
Hey, we can actually go higher than 5,000. In truth, we can. That's not a hard limit. We can crank you higher than that. So.
We have a question from Ken here, actually. Would you use one transit gateway with multiple routing domains or multiple TGWs? Now, I'm assuming that you were going to get to TGW, but I just want to make sure that Ken understands that we've got his question in mind.
Yeah, I'm taking my time. But the problem is we only have an hour these days, or 55 minutes, so I should hurry up and stop blabbing around peering. What I wanted to get to was limits, because this is where the important stuff happens. With peering, you can only have 125 peered connections to a single VPC. And also, I talked about, I'm trying to think of the real term. Is it NAU?
Yeah, NAUs.
Okay, so we launched with a different term internally. So there's another term I didn't want to use. And a network address unit is effectively an IP address inside a VPC. And so we did a bunch of engineering work over the last few years. We originally could go to around 50,000 in-use is the key term, in-use IPs in a single VPC. And you can actually have, I can't remember the math because it's been a while since I looked at this stuff, but you can have 50/16 CIDRs associated with a single VPC. How many IPs is that? Someone can do the math for me, but 50/16 CIDRs. But in the past, you could only have 50,000 in-use IPs. That includes secondary IPs. But now we have prefix delegation, so you can have up to 11,000 IPs assigned per EC2 instance through / 28 prefixes. But the point I'm getting to is the in-use IPs is a limiting factor here. We can actually have 256. I'm getting on my math screwed up right now. So no one knows this, Jamie does, but I'm going on vacation tomorrow and I'm going to be out for a month. So I'm going to go to Europe and take it easy and relax with my family. And so my brain is not on the game today. So if I screw up some of these numbers, that's why I'm thinking about sunny Europe.
I'll be right there to make fun of you about it. That's all.
Yeah, you can come along if you can fit in my suitcase. 256 in-use IPs for a single VPC, but then we've got a peered group of VPCs. You can actually do 512 in-use IPs. So there's some limiting factors around this peering mechanism. But what we basically were stuck against back in 2016, 2017 was this 125 peered VPCs. Like TechFuelD, 3,000 VPCs, we wouldn't interconnect them. How would you do it? The old days, you would actually use an internet gateway and public IPs and NATing. It's not pretty. Some folks still do that today.
Transit VPC, what we basically,
transit VPC, you'd use a VGW and you'd connect it to a host here, and then these hosts would connect to another VGW, and now you've built a transit through here, and these Cisco CSRs or routers or something were in high availability mode, and it got complicated really fast.
Yeah,
so what we said,
lots of lambdas.
Yeah, it was fun to troubleshoot. I was working in support at the time where we were getting a lot of cases. You could spend the day troubleshooting that scenario. CSR, whatever it is.
Well, you're basically saying, well, okay, I'm going from one VPC to another and it's peering, but like it's direct, but hold on. No, we're going through a VGW, a virtual router. We're going through another VGW. There's some BGP high availability there, some ECMP on the VGW at the time. It's not pretty. So what we did was we said, hey, this VGW, we need a multi-attached VGW and turn that into a hub. And so if we disconnected the VGW from the VPC. Jamie knows where I'm going with here. He's heard me talk about this a bunch, but what pen is that? So we basically said we need this VGW to allow connectivity like so. Now, our naming folks said, that doesn't make sense. Why don't we call it a TGW? And you know what? We're going to build a fleet of instances that supports the interconnectivity of the transit gateway, the TGW, so we can have massive scale. And so you can connect up to 5,000 VPCs to a TGW, and we use what we call hyperplane here. And so hyperplane is effectively an internal, highly scalable system that does packet processing. And so when you send a packet now from, oh, can I do this? I don't know if it works in, yeah. Okay, so when you have a packet going from an instance over a transit gateway, it actually goes through some packet processing, another instance, a fleet in that availability zone, and then goes onwards to its end destination. Now, the transit gateway was an amazing place to then say, let's connect DX. So you can have your on-prem or VPN. It's getting messy here. I'll clean it up in a second. But this TGW effectively turned into the hub of connectivity for everything within AWS. It's a massively popular service. What am I
would
missing
also
here,
call out Transit Gateway Connect too. Maybe Jordan wants to talk a little bit about that one because it's important when you're looking at SD-WAN and GRE tunneling and BGP.
Yeah, that was
It's a different
Jordan,
beast.
You can kind of talk me through this as I'm drawing it, so that you've got an SD-WAN, right? And you've got some sites. And then basically what customers were doing is saying, well, I want to have an SD-WAN head end connected to a transit gateway. And then I don't know why I'm drawing it sideways, but basically bridging my SD-WAN on-premises connectivity to a fleet here. We still see a lot of customers do this, right? I mean, this is pretty popular.
Yeah, it's pretty popular.
Set up your GRE tunnel, right?
GRE tunnels with transit gateway. Yeah, we'll talk about other options as well in a minute. I'll let Matt finish. But yes,
okay,
very popular to connect branch offices all across the globe.
Okay.
Absolutely.
So I'm gonna maybe throw it out to maybe Jamie or Jordan, whoever wants to take this one. But what I've got here is a pretty simple topology. And actually, I want to make a point here. When we released Transit Gateway, it wasn't that we wanted to deprecate peering. Peering has a zero data transfer charge in the same AZ, right? So you don't pay money going across VPCs when your two instances are in the same AZ, which is the way it should be. And so if you've got a Kafka cluster or something super heavy that's sending terabits a second of traffic, use peering.
And there is no data processing either, right? So
there's no data processing. The packet is going direct from one instance to another, and we're able to flip the bits on the VPC ID really fast. Transit Gateway, when you get up into TechFuel D's 3,000 VPCs, you're now beyond the limits of peering. You want interconnectivity, multiple route tables. You want to be able to go through maybe an egress security VPC. You want more flexibility. You know routing, but you want to have this routing hub that enables large-scale interconnectivity of VPCs. That's where Transit Gateway really comes into play. Now, I'll take it one step further in that folks, customers, maybe TechFuel D, I'm picking on you, but folks have teams that work on building Transit Gateway architectures. And I'll throw a question, Jordan or Wenzel or whoever wants to take it. What's the most complicated Transit Gateway architecture you've seen?
That will take more than an hour for me, but go ahead, Jordan.
No, I was going to say customers who use, who have workloads across multiple regions. And they are constantly adding or removing applications. So there is a little bit of routing, changes. So it's not an static environment. Going across regions, it's
the one that I've seen, which was pretty interesting, was by a partner who basically had different groups of customers, and they would have different customers connect to different transit gateways. It was all within the same region. They had I think they had to get special permission, but they had about 25 different transit gateways. And then to make it even more fun, they had hybrid connections to different transit gateways as well. They had to connect them all together. And then they had to separate all of their routing domains and their propagations to make sure that they didn't get any customer cross connect, but they could still get access to everything. And they asked me to help them build it. And it was fun. It was cool. And I think I lost a couple of strands of hair on that one. But it was, I mean, it's doable.
Now that you mentioned that, I remember talking to a customer. We changed that, but back in the day, they were using a transit gateway for every single like routing domain that they had, instead of using different routing tables and whatnot. It ended up being, can't remember, but like I'm talking like, I'm gonna say a number, but I don't know, 50 or 60, whatever it is. But they were using like 50 or 60 transit gateways that they were independent routing domains. They needed to talk to each other sometimes. It was a little bit of a mess. So we changed that now, but it's yeah, that was challenging.
So TechField, are you referring to my story, or are you referring to Jordan's story? Because I wonder if I helped you on that one.
Okay.
But one other thing too, I want to make sure as you're drawing that, I'm going to ask you a question while you're doing this. Let's say we want to go, or maybe Jordan, if we want to go absolutely crazy, right, and get the most speed through a connection between two different VPCs, what do you decide, peering or transit gateway, and why?
Peering, absolutely, because you don't have to send the traffic through like a fleet of instances, as Matt was saying, to process the traffic and then back to like wherever it needs to go, right? So if you're talking about like performance-wise, then peering, it will get a slightly better performance than going to the transit gateway. We're talking about like something minimal, like I don't know, Matt, if we can throw the numbers like 1-2 milliseconds, whatever it is, going to the transit gateway. But yeah, for performance,
it's actually like this. So the TGW packet processing instance, that's not an official name. Don't reuse that. I just made that up. But basically, if you've got two instances, and let's say they're in separate VPCs, I'm trying to do this simply so it doesn't get complicated, and we're kind of encroaching on my other diagram. Let's see if I can finagle this out of here, maybe. Oh, it kind of worked. Okay, let's go over here. We lost a VPC. Okay, so basically you've got instance X and Y, and then A and B. A and B is connected via a transit gateway. X and Y is connected via peering. This is direct. It's like 1 millisecond, say, inside the same availability zone, generally speaking. A transit gateway, I think we would expect something like 1.5 milliseconds-ish, something like that.
So
you're going to see an increase. Yeah.
Okay.
Don't quote those numbers because everyone's environment's a little different. You compute, and the way it gets stacked within our data centers is obviously different for everyone. But this is what's this circle? This is basically what it would look like.
What if we're using placement groups, right, and advanced networking, and we're going from AZ to AZ over a peer versus transit gateway? Do you see any difference? Or?
Oh yeah. So I mean, now we get into. I'm going to draw a topography map where we're still. Our industry is really just boxes and lines. I mean, let's be.
That's all it is. Sometimes the lines are squiggly, sometimes not.
Okay, so I'm going to do this, and I'm going to draw. This is a topology of a region. And so an availability zone would be this, AZ1. And so the reason is we have, whoops, I accidentally erased it. The reason we have different fiber feeds coming in and power feeds, then another availability zone, this could be AZ2. And so if you've got compute that is deployed in a placement group, you're going to be probably in the same building like so, same rack, right? Super low latency, physics right close next to each other. That's why placement groups exist. If you're over here or over here, you may be in a different data center in the same campus, in the same availability zone, interconnected very fast, right? And so you might see that 1 millisecond. Now, because of physics, these buildings connected to each other, they may be, I mean, you can see with, what do we call that? Infrastructure performance monitor, I think is the right term.
Yes, I think you got it right.
We changed the name of some of that stuff recently.
Yeah, I would have spit out the name under development, which is.
Yeah, well, you can jump in there and see what the availability or the latency is between availability zones. And this might be 2 milliseconds, this might be 1.5 milliseconds, this might be 3.5 milliseconds. And so if you go from, I'll draw a red instance over here, talking to a red instance deployed over here across availability zones, you're now going to probably be 2 milliseconds plus, because you've got this interconnectivity link here, which is at 2 milliseconds. And I think what I'm really bad on my public quotes, which is terrible. I need to revise them. What do we say our regions are all within a 50-kilometer radius or something like that, which equates to 5 milliseconds?
Yeah. On its own floodplain, one burns down, the other one stays up. Kind of, we do a good job of looking at the area and making sure that if something happens, it doesn't take out the whole region.
Exactly.
Hence
Yes,
the whole
this
point of
fails.
everyone telling you multiple AZs, please distribute your workloads across multiple AZs.
Exactly. Okay. I think we're getting distracted, but this is all good foundational knowledge. I want to come back to this. We didn't talk about this, but Transit Gateway is a single region construct. It's a region level construct. And so connecting across regions, we've got region A, B, and C. We've got multiple transit gateways with cross-region peering. Now, what we can also do is intra-region peering. And so this is what we would actually call a hierarchical transit gateway deployment, where you've got a tech field D, picking on you again, sorry, man. So basically multiple transit gateways, different business units maybe. This could be finance, and this could be app dev, right? But then this might be engineering. I'm making up names here as we go, but
it's also companies who merge, right? Acquisitions merge. So
yeah, the merging company where you grab from their infrastructure into yours and you do your best. Hopefully they're not using the same IP address scheme, because that is a limitation for both peering and transit gateway, is both sides need to be uniquely addressed to follow standard routing rules.
I think we might have bottomed out on transit gateway here. This looks pretty complicated.
Yeah, you went from 200 to Matt Lewis.
Well, we didn't add route tables here either. Like you can have multiple route tables here, right? Let's put an egress security VPC here with 2 firewalls that talks to the internet. And
how
now
about
these folks can talk
ECMP,
to
VPN?
this. Oh, well, I'm running out of room. Let's put another on-prem TGW, which has some VPN connections to another cloud provider, maybe.
It could be because of the active-active VPNs. It's one of the things with site-to-site VPNs, which is kind of a cool thing that I loved, is they made it so that it's no longer a passive receptive thing. You can actually initiate a connection now from AWS. So the cloud thing, keeping that alive, is a lot easier.
I've got a circle here, but we don't need that. That's just over the public internet. Or we could have a DX. I'm going to save the DX piece for when we start talking about cloud WAN. But yeah, you can connect other cloud providers, on-prem data center. Yeah.
I got one from Lucky Lordy here. I don't know if this is too off topic. I'm referencing refactoring an AWS environment from a single account to multi-account, and you need a good networking account. Should I use Transit Gateway for pluggable network and share ingress and egress through a firewall? So I think Lucky Lordy is talking about a single egress pattern or a shared ingress pattern using Transit Gateway as he's going to the multi-account. What would you recommend there, Matt? Just off the top of the head, or Jordan?
Oh, man. So I want to make a sticker, and it's kind of a cop-out, but it says something like, I'm an architect and it depends.
Well, Lucky Lordy just said he got it. He wants a single ingress egress paradigm now.
Okay, so it depends. It really depends. So building an architecture that basically goes from single account to multi-account, I think it's a common question. It's a great one. We could have a whole session on that. But basically, you've got a single VPC, single account, and you've got some stuff that's spun up in there. And then you're like, well, hold on a second. I should draw a different color for the account. We've got another account over here, and VPCs are not well, I'll get to that, but not a cross account construct traditionally. It's just a single account construct. I'll talk about peering in a second. But you basically have another instance over here, and now you're like, well, hold on, as an administrator, now I've got to manage this stuff. What's the best way to manage the interconnectivity? Should I just have a TGW, which, mind you, has cross account connectivity? Should I use peering, which has cross-account connectivity, but then there's no checks or balances between the two VPCs? This is a VPC, this is a VPC. There's no checks or balances between there. I don't have a point where I can do firewalling. Well, you kind of do, just in that you can have security groups. Mm-hmm. If you manage these accounts, you can have NACLs. But what some customers will do, and I think that's to your point, where you would say, hey, I want some firewalls, and I'm trying to think of how to draw this properly. This is probably not right, but you could do something like this, where you have transit gateways sandwiched between some firewalls. And now basically your transit gateway, this could be one transit gateway and you're using route tables. I'm just drawing for simplicity's sake. It's horrible drawing. But basically the packet then would, whoopsies.
Trying to get fancy
back
there.
then, trying to get
Yeah.
fancy, would go from your instance over a transit gateway, would go over your firewalls, and then back over a transit gateway, and then go into your instance. Now you've got this central point. The downside of this architecture is you manage these fleets of firewalls yourself. They're instances. They need to be highly available. You can build highly available using Transit Gateway Connect and GRE, and a lot of our vendors now, firewall vendors on AWS, support things like GRE or even IPsec. But to scale this fleet out can be cumbersome. I think, Jordan, this might be a good time to transition to Cloud WAN, because we've got some native stuff in Cloud WAN that actually helps with this particular piece. And I think we'll get there and show that architecture.
I will also interject that VPC Lattice could also be a good solution there too, depending on how you want to do your communication between your different services. You can do a common egress. And then instead of having to rely on firewalls inspecting all of your east-west traffic, north-south, Matt, you're still right, but east-west, you can still use the IAM policies. And now, generally now, the auditors and that will accept your exported policies as firewall rules that they can inspect. But back to Jordan for Cloud WAN.
Well, I before we do Cloud WAN, I feel like we're missing a whole bunch of connectivity services, and Lattice is one, PrivateLink's another. So basically,
Resource
you can have
endpoints.
a VPC that has a Lattice service network, which connects. I'm drawing this really terribly right now, really quickly, because we want to move on. We only have 55 minutes, but basically, load balancer app like so in a VPC. And then Lattice will basically drop an endpoint that you don't really see. It's a 169.254 address. But this service here can then talk via the Lattice network or Lattice service network up into these applications. Likewise, you could have PrivateLink, which basically looks like the same architecture, connected to a NLB to an application. And this PrivateLink will basically drop an endpoint. And then this application can just talk to these endpoints. And they're talking to these applications that are actually in different VPCs.
One more,
Right,
Matt.
so-
Draw another endpoint, and then you can do what's called a resource gateway. And that resource gateway can also point to other services that are either on the internet, on-prem, or in another VPC. So you can get
Without a load balancer too.
without a load balancer at all. And you can use Route
Something like
53 to
this.
do your load distribution. You can get crazy.
I think, I have a problem with everything that we're doing here. I mean, Jamie, you and I are in the service team here, and we kind of invent this stuff. I have a problem with everything that's happening here because it's just too complicated.
It's getting
You know
complex.
what we
Many
need? Just a quick
endpoints
aside.
and-
We need to do a show where basically one of our members, audience members, gives us a problem, and we can see which one draws a different architecture to that problem.
Oh, yeah, you're right. And you just reminded me, I skipped over it. And this goes back to the question from Lucky Lordy. We were talking about this, but you can also do shared VPC. I forgot about that.
Oh, yeah. I forgot about that one.
Where you can have a subnet and you share it to this is our blue is the account. You've got an account with a VPC, and then this subnet is shared to another account. Oops, that's not blue, but let's do this. And then that account can spin up things like EC2 and Lambdas and other things inside that subnet, even though they're in a separate account. And so we see customers say, I want one VPC and I'm just going to share subnets out to other accounts. And they have privileges to spin up things in my VPC. But as I'm the VPC owner, they're participating in my VPC. I control the routing. I control the internet gateway, the firewalling, the connectivity, and all that kind of good stuff. So
you see a lot of that
sharing.
with organizations that have a networking group that kind of controls all the networking constructs, and they'll do VPC sharing. They'll own the transit gateways. Maybe they'll own the service network for VPC Lattice. So it's a common thing that you see in the larger enterprises.
Now, a disclaimer here. I see the question from Mikabolic. I hope I said that right. This is not cross-region because a subnet is an AZ-bound construct. You spin up a subnet, you tie it to an availability zone inside a region. And that's because that subnet constitutes compute inside an availability zone. If we go back to, did I delete it? No, it's here. We go back to our data center. Inside this data center, like the subnet is bound to, this is an AZ, the subnet is bound to the AZ where compute gets spun on different racks and different compute, but it's all within the same AZ. I was actually advocating internally for a region level subnet so folks could spin up instances in separate availability zones, but have that subnet stretched across the region. The problem with that is each of these availability zones has a control plane. And what we actually did is the opposite of what I wanted. And we isolated these availability zones from a control plane perspective as much as possible so that we didn't have an issue that happened on this AZ that affected other AZs. They're completely isolated. And so by having separate control planes for the region and availability zone, we keep everything separate, right? And that's why you'll see things that are bound to an availability zone. Transit Gateway spins up resources in every availability zone and then has an orchestration that operates across those as a transit gateway. So it's a region level construct. A VPC, it's getting chicken scratch territory here, operates across the region as well because it's a software defined construct as well. It's not a physical construct that operates inside an AZ.
And for our 200 level comment, remember, you can have multiple subnets on an AZ as well. You can create more than one subnet.
Many. Yep, that's true. I think this is a good time to talk about, I've complained about complexity.
We're 41 minutes in. Okay, Jordan, talk to us very simply about, Cloud WAN and, make it
Sure.
snap.
You want to share your whiteboard here?
Okay, just share it now.
Jamie, you can add it in because otherwise we're going to do the whiteboard shuffle and it's going to go blip, 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 blip.
Yep, I am adding to stage. I think we need to take you off first, Matt.
All right. So what about now? Can you guys see
He said, you're telling me to do it. You're moving yourself. All right, Jordan, it's all you. You're up.
All right, amazing. So we talk about.
Hey, Jordan, you want to just move your mouse off your recording and then that little box thing will. Yeah, there we go.
Much better now. All right.
Yeah.
So we talk about VPC peering. We talk about transit gateway, and then we saw how. Can get a little bit complex when you start connecting a lot of those transit gateways and whatnot. So the next topic, I guess we need to talk about is Cloud WAN, which I saw a few comments on the chat about some people talking about like Cloud WAN, how we make a little bit the life easier for that. So how we will define Cloud WAN generally is we call it like transit gateway on steroids or something like this.
So I actually, the way I think about Cloud WAN is we have transit gateway as a data plane construct that we built that's immensely powerful and scalable. But we wanted some kind of orchestration layer that operates on top of this, that manages everything for you, that you don't have to go and spin up 5 different transit gateways and worry about all that stuff. And so I think of Cloud WAN as like an orchestration platform for transit gateway. Transit gateway is still under the hood.
And to make it as easy as possible for infrastructure as code.
Yeah, for automation as well, right?
Right.
So especially for customers, I guess, who are in multiple regions, they're looking for that global construct. That's where Cloud WAN can make a little bit like the life easier, I guess. So let me draw it out. So let's use single line in here, where a customer has resources across multiple regions, right? Now, you can use transit gateways, and it works very well. It's one of my favorite services. Still remember when it came out. But with Cloud WAN, what you can have now is instead of having these regional routers, you can call it, or virtual routers, you can have like a global router, right? And within this global router, which we call Cloud WAN, we can then have what we call segments, which is the similar concept than in transit gateway you call route tables. So now the route tables, instead of being regionals, you can have them like being like a global, right, across regions. So let's draw it out. So we can have different segments we call in Cloud WAN. For example, one for production, and then
let's put some labels here. Like, what are we looking at? Yeah. Regions, AZs, subnets.
Okay, so in here we can say this is region 1. Okay, this will be region 2, and this can be region 3. Okay, and then we build our Cloud WAN, which will be our global backbone, we can call it. Sometimes we refer to it as C1 for Cloud WAN. And then within the Cloud WAN, we then build the segments. For example, we can have which again, segment is a routing table. Okay. So we can have the production segment, for example, production segment here, and then we can build another one for a different type of workload, like development, whatever it is, right? Now, when customers have like VPCs across all different regions, it makes it very simple for them to connect those VPCs. So let's draw like a VPC, for example, in region 1. Okay, and this one will be, try to use the same color. So this one, I'll be using the green for development. And then on region 2, we might have a couple of VPCs. One will be for development as well. And then we'll draw another one like production in here. I'll try to use labels, I know. VPC, it's gonna be VPC 1 as well. And this is gonna be VPC 2 for development. Then we have VPC 1 for production. This one is gonna get connected to the production segment. And then we're gonna have another VPC here. Okay, this is gonna be VPC 2 for production as well. Now, by default, VPCs connected to attached to the same segment, they can talk to each other freely, which makes a difference, I guess. Again, transit gateway, I like it a lot, but you have to connect those transit gateways together. You have to pair it with Cloud One. You can now achieve like the same thing, but globally. Now, by default, only the resources on the same segment can talk to each other. There is an option as well, which is like to share routes across the segments. You can think about the segment as a VRF, and then if you want to share the routes, there is an option to share routes across the segment. So in the event that you need it, to share those two segments or two route tables, you can do that. Now,
well, let's add the topology we're talking about before was we had some firewalls that we were using to do inspection between two VPCs. Like, what would that look like here?
There is a feature in Cloud One called network function group. Okay, we can draw the network function group as looks like another segment, but it's a managed segment, you can call it. Okay, and it's a NFG network function group. Now, on this network function group is where you will attach your firewalls. I'm gonna try to draw them in. I'm gonna use firewalls. Let's say in this basic example we have 3 regions on the whiteboard, but let's say there are 2 main regions, and one of them is just like a satellite region. Like there are not a lot of resources. Like the customer is operating mainly in 2 regions, but then we have a 3rd region which contains like limited amount of resources. Okay, so we're gonna put firewalls for a cost perspective only in 2 of those, the 2 main regions. Okay. We're going to put a VPC here, which is going to be our inspection VPC. And within that VPC, then is where we'll have our firewall. So this is one of our main regions, region 1. We're going to do the same. And I should have done this in yellow, but just to keep the style the same. But anyway. Style. Okay, let's see. Okay, it worked perfect. Now let's go back to another one in here, which is also going to be one of our main regions. Another VPC, another inspection VPC, where we also have our firewalls in here. Now, let's say like VPCs from development wants to talk to VPCs in production. And instead of just sharing routes across those 2 segments, production and development, we want to have some sort of like inspection in between, like to say, okay, this traffic is allowed or not, right? With Cloud One and network function group, we can actually choose like from which segment to which segment the communication should go through a firewall. For example, let's say from production to development, I want that traffic to be inspected. And then the second thing you can also choose is if you want that traffic to get inspected in both regions or only in one region, which is one of the cool things about Cloud One, right? You don't have to inspect the traffic twice unless you want to, unless you have some sort of like compliance requirement to inspect the traffic in the local region, right? So the life of a packet will look like this. So we will have, let's see if I find there we go, the right tool in here. Perfect. So if we have, for example, VPC 1 here in development, wants to talk to VPC1 in production, right? By default, they cannot do it because they are in different segments, but then we can have the network function group, which essentially what it's going to do is going to get the routes from this segment in production and share it with the network function group, and also the development segment is going to share those routes with the network function group. So if those two VPCs want to talk to each other, now traffic is going to go to the development segment. It's like, okay, I want to go to production. To go to production, then automatically, again, you in the console just go, okay, from this segment to this segment, I want those to be able to talk to each other, but through a firewall. So automatically, it's going to inject the routes. So traffic is going to get sent to the firewall, and then from the firewall, it's going to get back to the network function group, which again, will have the routes to go back to, in this case, we're going to the production, which is this one, right? Does this make sense, Matt?
Yeah, I mean, if there's any questions in the chat, feel free to chime in.
There's one right here. Can you provide an example of what kind of an inspection the firewall would do?
Yeah. Okay,
I want to say any type you want, but feel free to go ahead and color that.
No, I should have mentioned it. Actually, when I'm saying firewalls, okay, I didn't specify. So when I say firewalls, you can either use the AWS Network Firewall, or you can use your own through like whichever brand, not to mention it, but Checkpoint, Palo Alto, whatever it is, Cisco, any brand your choice, you can also deploy that in here. And it works in the same way, like there is not much difference. Then the traffic you want to spec, it will be up to you. For example, with AWS Network Firewall, you can do 3 different types of firewalling. Like you can do like layer 4, you can do like layer 7, or you can do like some sort of like DNS filtering domains and all of that as well, right? So it's up to the user what sort of, if you want to do deep packet inspection with a third party, you can do it as well. So again, that's up to the customer, right?
So just to put it simply, there is no restriction on the firewalling type. It's totally up to you.
No.
This is just natural as it would be. It doesn't restrict you in any way.
Correct. That's correct. What else are we missing here? Maybe like hybrid connectivity.
Well, there's chatter in the comments here about timing here, and we're almost out of time, and that sucks because there's just so much to talk about, and we didn't really get to on-premises connectivity. But maybe just draw a direct connect, and how would that connect to a cloud WAN?
So let's, for example, very quickly, I'm gonna get rid of this. Okay, so now let's say you also want to connect your on-prem resources, which, by the way, with Cloud One, because generally we think like customers across multiple regions, right? A lot of customers have on-prem resources, which they want to connect to Cloud One, to AWS. Now, the way to do it through Cloud One, now you can have the Direct Connect Gateway, which is our global, for those who don't, who are not familiar with that, think about it as a VRF. Okay, so when you connect to AWS via Direct Connect, which Direct Connect is basically like plugging a fiber into our router. Okay, and then you have the option to do it directly to the BGW, the VPC, or you can do it through like a Direct Connect Gateway. A Direct Connect Gateway is this global VRF that allows you to connect to any region. Now with Cloud One, what you can do is you can terminate your direct connects. Let's say we have a direct connect in this region. Okay, for short, I'm gonna call it DX, and then you can have again another direct connect in another region. Now you can then advertise the routes from on-prem to this Direct Connect Gateway. I'm gonna put it in here, Direct Connect Gateway, and then you associate the Direct Connect Gateway to Cloud One. Now, something I didn't mention, which doesn't really matter a lot, but something to keep in mind, under the hood, Cloud One runs like a Transit Gateway-like component, which is called the CNE, Cloud Network Edge. It's all managed, so customers don't have to do anything. But again, under the hood, we run it, right? So it's like a Transit Gateway-like. And there will be one on every single region. Now, the reason I'm mentioning this is because when you connect I'll get to that in a second. I'll throw another one in here. When you connect when you associate your Direct Connect Gateway to Cloud One, then you can choose to what regions you associate that to. Generally speaking, we will, unless you have a reason not to do it, we will recommend to associate it with all the regions. So the Direct Connect Gateway gets associated to all the regions in Cloud One. Again, unless you have a reason not to do that, which there are. Like there are some cases which the customer want to have like different direct connect gateways with different associations to different regions like whatnot. And now with that, you're basically achieving like a bidirectional routing. Like from on-prem, you can advertise the routes to AWS, and from AWS, you can then also get the routes advertised to the DX gateway and then back to the on-prem. Now, with that being said, what else? What else are we missing here? Obviously, like the SD1 we were talking about before, but sorry,
I think like this diagram is actually very similar to like if I just switch over to, I started drawing this if it was transit gateways, and I stopped because I started not listening to you and I was missing stuff, so I stopped drawing this. But here, this is okay. We've got route tables, we've got transit gateways, we've got a VPC we're managing with some stuff. We've got multiple VPCs attached with peering connections, multiple regions. It's a similar thing, and it looks very similar. But I think the key point here is you're not managing the deployment of all of the stuff in the center here. You're basically defining these objects through infrastructure as code as well, and they just get deployed for you across regions. So instead of having to rinse and repeat this work or automate this work yourself, it's already been done for you with Cloudware, right? And I think that's the powerful piece of it.
One comment about that is, question I guess I can say for you, Jordan, is can you do this through the console, or can you only do this through policy?
No, both. So you can do it through the console, or you can automate this. Actually, with Cloudware, we don't have a lot of time now, but I'd love to talk more about it. But yeah, basically we have like the tagging system. Like when you create like an attachment to a VPC, you put a tag in there, and with that tag, it automatically gets picked up to what segment it goes to. So it's been designed for automation, but absolutely you can do it through the console as well.
Perfect. Yeah, Anusha has just put up some more links about Cloud WAN and DX and automation and associations.
Hey, we are at time, but Ken just had a quick comment. DX gateway integration from non-direct regions and need to use TGW maybe.
You mean for regions where Cloud WAN is not supported, or where what's?
Yeah, I think that's it. Is Cloud WAN across all of our regions now?
So there are a couple of a few regions actually, like China regions and Brazil. So it's supported in most of the regions where transit gateway is, but not in all the regions. So yeah, there are some workarounds to set up a local transit gateway on the region that Cloud WAN is, peer that to a region where it's only transit gateway available and not Cloud WAN. There are some workarounds, but it's mostly available in all the regions except a few, I think it's a few regions. I can't remember the name exactly, but
yeah, just to put a note on that, it's not that we don't want to put them in those regions, but those particular regions or the areas or municipalities that they would go in have specific laws on how they handle data going in and out of their countries. So we have to be very cognizant of the fact that we can't create a global, WAN that makes it real easy to have data going in and out of the country when it's not allowed.
So I know we're at time. We are actually going to be talking about transit gateway and Cloud WAN advanced connectivity architectures next week. So I think this is a good precursor. But before we kind of close here, Jamie, you were doing some whiteboarding whilst we were all talking here.
Yeah. Yes, I was. I was drawing Matt.
I see the likeness. No, in all seriousness, that was us trying to figure out the orientation of a shared whiteboarding tool that we were looking at using. And so you've got to draw, one person draws in a spot and then everyone else has to zoom in on that spot. So, anyway, we're out of time. But Jamie, over to you, man. And thanks, Jordan.
Yeah, thanks again, Jordan. Yeah, folks, so if you'd like to see any type of sessions, like if you want to see the dueling whiteboarding or anything more about any of the things that we've talked today or something we haven't figured out, please, by all means, throw that up in the chat. We do take this in as guidance as to what we do for our new shows. Also, please make sure you go over to theroutingloop.net. This episode and all of the previous episodes that we've had for, I think, a couple of years now, Matt, are all up there as videos that you can kind of look at on demand. And we also have a spot there for you to be able to tell us how we're doing, what you'd like to see, all of that stuff. So yeah, please head on over there. Jordan, thank you for joining us. I know you had to suffer through Matt and I always bantering back and forth and talking. Matt, always a pleasure. I hope you do enjoy your vacation. Please don't give me too much work to do when you leave. And for everyone else,
you better believe it.
Have a great day. Thank you, everyone, for joining us.